Good morning, everybody. Thanks so much. Natalie, as Natalie said in the introduction, my name's Simon Mitchell. I'm the Vice President Resilient Habitats at WWF Canada, and I'm coming to you today from my home office on the Wolastoq, the traditional territory of the Wolastoq. And I will give Megan a quick moment to introduce herself before I move into the outline.
Thank you, Simon. My name is Megan de Graaf. I'm the director of the Acadian Forest Program for Community Forests International, and I am in my home office today, which is in the bustling metropolis of Harper Settlement, which is nowhere that any of you know, but it is in the Anagants River watershed, which is in the traditional and unceded territory of the Mi'kmaq.
Wonderful. Thank you, Megan, and good morning. Good to see you. Next slide, please. So our outline for today is fairly straightforward. We're going to provide a bit of context around climate change and natural assets along the Wolastoq, and then we'll get into some detail around the Florenceville-Bristol case study, which I'll speak to, and then Megan will speak to the Cambridge Narrows case study, and we'll have some time to wrap it up in the end and take some questions and have some discussion. Before we start, though, I do want to say that there are a number of people and groups on this call who have been involved in similar projects. I see that James Bornman is here from the Southeast Regional Service Commission, and they've done some interesting work around municipal natural assets in the same cohort of projects that I was involved with at Florenceville-Bristol. We're also aware of some work happening up in the northwest part of the watershed, led by Adrian Prado at the Northwest Regional Service Commission, and there certainly have been some other projects happening around the region. So this isn't the be-all and the end-all of natural infrastructure and natural assets here. This is two examples of the work that's happening in the region. We just happen to be on Natalie's hit list for making a presentation, and for that, always grateful for the opportunity to share some of our work and take questions around it. Next slide, please. Bit of context for this. You've all heard me say this probably many times before, and we're in a critical point in time here with this dual crisis of climate change and biodiversity loss, and certainly some of WWF's assessments over the last number of years have really highlighted this. We rolled out Living Planet Report Canada in 2020. This was an update from 2017, and unfortunately the situation isn't improving on the species front. In fact, of the species protected under SARA, there has been a 28% decline in their populations between 2002 and 2014. And as you will see, as this discussion and presentation moves forward, the link between natural assets, climate change and biodiversity is undeniable. And by working with natural assets, not only can we address the climate change piece, but we can also address the carbon piece and the species piece, which for us here on the St. John River is just so vital. We have over 50 species listed throughout the watershed, fishes, plants, bugs, insects, all sorts of things, and we need to be doing everything we can to bend the curve on both biodiversity loss and climate change. Next slide, please. So getting to the climate change piece, what does this mean for this watershed, which, by the way, is the largest drainage between the St. Lawrence and the Mississippi at 55,000 square kilometers. It is larger than the province of Nova Scotia. And as the health of the St. John River goes, the health of the Bay of Fundy and the Gulf of Maine goes, and vice versa. And that's all to do with the movement of nutrients in and out of these two systems. When we're talking about climate change here, really it is about the increasing frequency and intensity of rain events, which leads to flooding and associated problems. So, this time of year, we're all sort of sitting on pins and needles as we wait to see how the spring freshet goes. The freshet's been happening for thousands and thousands of years. The problem over the last decade or so is that this has led to an increased frequency and intensity of a freshet extensive flooding, and we only need to look back to 2017 and 2019. At 2 years, not far away here. It's not long before we lose track of when we've had significant flooding, but this is a serious problem, not only for species and wildlife and the habitats that they depend on, but also is a significant issue for municipalities, for people, and for the businesses up and down this river. It leads to habitat degradation, water contamination, and pollution is a big problem when we have extensive flooding. And on that last point there, the other side of this equation is that we are seeing some very dry summers. Last year was a good example, as I understand it. That was the driest summer and the lowest water levels since 1924 in the province of New Brunswick. So climate change is all about extremes. We often spend a lot of time talking about the flooding piece. That's the piece we're going to talk about today. I think more often we will also be talking about the drought side of the equation, and what that means, and the impacts can be very significant when we start to think about our forests and particularly our agricultural industries and even homeowners here in New Brunswick. We have a high propensity for people to be on wells, for example, and when water levels get low, wells start to dry up, and that leads to some significant problems. Next slide, please. What's interesting, and I've already alluded to this, is that all of our climate impacts, for the most part, are experienced through fresh water throughout this watershed. So the top left picture is some erosion that's happened on a roadside immediately adjacent to a stream in the Florenceville, Bristol area, and there's a bit of gray infrastructure that is laying on the ground there. That culvert, that's not where it's supposed to be, but through surface runoff and flooding in stream, this has led to some significant issues. Rivers shouldn't look like a bad cup of coffee in the morning on the bottom right there. This is actually in a little tributary off of the Nashwauk, and this is from heavy rainfall leading to sediment loading and pollution and everything that comes along with that, which obviously is significantly degrading habitats. And the picture on the right is from a couple of years ago in the Heartland region, just below Heartland. If you look very carefully at that picture, you can actually see the Heartland covered bridge sort of mid-center of that image. Folks who aren't familiar with Heartland, you'd be interested to know that like many of the communities along the St. John River, the sewage lagoon, the water treatment facility, is on the lower end of town in the floodplain. And I can guarantee you that in this image, that sewage lagoon has some serious issues with ice more or less moving right through it, much like we saw in Perth Andover during the flood of 2008. Next slide, please. So that was really broad, picture of the climate biodiversity crisis and some commentary around natural assets and their value. I want to spend the next little bit talking about Florenceville, Bristol, and our project up there over the last couple of years. We've been working with the municipalities along the valley part of the region, so Wolastoq through Florenceville, Bristol and above, for about 5 years now, initially starting on climate vulnerability assessments, then moving into adaptation plans, and then an opportunity emerged through the Municipal Natural Assets Initiative, MNAI, which is a collaborative national project that involves all sorts of groups, and it really is about the rapid mobilization around understanding our natural assets and what do we need to do to protect them, and in some instances restore and rehabilitate them such that they provide the services that communities need, so flood attenuation and all of that good stuff. This here is a brief outline of the steps that we took with the municipality. And when I say with the municipality, I mean, you know, the CAO, I mean the Public Works Director, I mean residents, I mean business owners, I mean people from neighboring Indigenous communities, and really just sort of climate champions, essentially, that are interested in natural assets. It was a 1.5 to a 2-year project that was guided by the folks at MNAI, but did put a fair bit of responsibility and onus on the municipality to engage and support the project. And started off with, you know, basic webinar. Well, actually, sorry, at that time, this was pre-COVID, so we actually met in person. Imagine that. And, you know, then continued on with a condition assessment, which I will speak about here in a moment, some mapping, some flows modeling, and then, you know, developing operational plans and a management approach. So this is, you know, this is about some very technical stuff, but also at the same time is about things at the municipal level, like bylaws and subdivision development plans and that sort of thing. How do we help those communities shape this work so that it can be of the greatest asset to them? And one of the reasons we decided to work with Florenceville Bristol, apart from having an existing relationship there, is that these small communities up and down the river, of which there are quite a few, are quite under capacity, both on the financial sense and the human resources sense. So, for example, Florenceville Bristol does much of their, they don't have a GIS person. They don't even have a GIS system. And so they're using consultants and outside third parties to help them with a lot of their municipal operations, particularly on the planning side, on the gray infrastructure monitoring and assessment. And so we felt it was an opportunity to really bolster their capacity and give them an opportunity to pursue some of these things moving forward. That's not to say that some of the larger municipalities don't face some of the same issues. I know some folks are on here from the city of Fredericton, and there are challenges at multiple levels with this work, it being so new, and communities really grappling with not having enough capacity and understanding to move the work forward. Next slide, please. So this is our study site in Florenceville, Bristol, and I apologize for the quality of the image, but what you need to really grab onto here is that on the top left is Route 105, and essentially right in the top left corner is the St. John River, and that lower gray area there is a subdivision built on a terrace sitting just above the Wolastoq River. And the rest of this here is color coded to identify the assets and what condition they are. For the most part, this is a forested region, so these different colors represent different types of forest stands or forest communities with a bit of agricultural land thrown in. And the issue was that there was increasing runoff coming from this region that was impacting the subdivision, was impacting the subdivision as well as the infrastructure. So, you know, culverts were blowing out, and in a number of instances over the past couple of years, the road wasn't passable at the 105. The culvert, you know, headed out into the St. John River, which is obviously problematic. But from an emergency response and community perspective, it was also a really big problem because there was no workaround to get the fire truck and ambulances and those sorts of services to people who may need it on the other side. From my perspective as a freshwater guy, you know, we're concerned about water quality and runoff and sedimentation over and above some of those community concerns. And that was why we were tackling this project, because it is highly replicatable in other regions of the watershed and the province more broadly. Next slide, please. So part of this work, as I outlined with the community, was the beneficiary considerations. So looking at the natural assets and understanding, you know, what is who benefits from this asset, and maintaining it in a usable and functioning way. And what's the trickle down effect to this? So, when we talk about water quality improvement, that impacts people at the local level, but it also has a significant impact on the river, and human and natural communities downriver. And obviously keeping soil on the land is an important thing, not only for people who live in the subdivision and want to keep their lawn in place, but obviously also the agricultural sector, which was further up in the watershed, needs to keep their soil in place. That's what they grow potato and crops on, and it's rather expensive to be fertilizing any more than is absolutely necessary. And then obviously the municipality and the taxpayers in the region want to keep their gray infrastructure in place and functioning as much as possible, because it is expensive to replace it and or upgrade it if there is an ongoing problem. And once there was an incident, and there's a number of communities where this has happened, where gray infrastructure culverts have been replaced 1 year and it was upsized, but apparently it wasn't upsized enough, and before you know it, they're back 2 years later doing the same thing over again. And that really is not a good way to be spending taxpayers' dollars. You have not addressed the core issue. Next slide, please. So we looked at a couple of scenarios as it related to runoff in this catchment and how it was impacting the infrastructure. So we looked at it, how it currently happens, and then also what would happen if that forest was changed. And the obvious change would be to agricultural use, with a sub-use or a second use of further subdivision development and or expansion. And then we looked at these scenarios based on the 1 in 5 year storm, the 1 in 100 year storm, and a 1 in 100 year storm plus 20%. The thinking being that maybe the projections are a little off and we need to be a bit more aggressive in our thinking here. And you can see in the table at the bottom that there was some significant increases for peak flows based on these scenarios. Next slide, please. The end of the day, for our case study, we came to understand that that forest was providing about $3.5 million worth of stormwater management services. This would have been the replacement cost to put in retention ponds, stormwater settling ponds, and that sort of thing. And so apart from not being overly feasible, it does make sense to be maintaining that forest in a healthy and resilient manner, because it is benefiting not only wildlife, but also the community and the residents downstream. Generally speaking, the research is showing that maintaining and or rehabilitating green infrastructure is the cheaper and more resilient solution than increasing or improving gray infrastructure, which generally means upsizing culverts and that sort of thing when we're talking about examples such as this. The municipality has moved on from this work. We're currently doing a natural asset inventory with them to really expand this thinking across the whole community, and they have incorporated some of this in their bylaws and subdivision planning, and will continue to do so moving forward. And with that, I will pass it to Megan.
Next slide, please. So I just want to take just a quick second to say that Community Forest International has a number of really interesting programs. So I'm going to ask everybody to go look at our website if you'd like to know more what we do than what I'm going to describe today. But in general, our work is all revolves around addressing climate change through mitigation or adaptation, and we focus on enabling communities and forests together. So we really think there's a way to have your cake and eat it too. For this particular project, though, we really focused in on some of those adaptation questions. Next slide, please. So what we're calling the Cambridge Narrow case study here has another project name that you might hear in some of our social media or other places, and that's our Forest Infrastructure Adaptation Project. We really came to this project responding to a lot of the things that Simon already covered. And by the way, I'm really excited when I get to go second in a presentation like this, because Simon did a heavy lift already. And I don't have to go into much of the context or tell you about climate change because he already did that, which is great. Thank you, Simon. But as we all know in this province, the role of deforestation in flooding is really hotly contested, right? There's a lot of debate in this province about exactly how forests and deforestation, how they relate to flooding and flood or water regimes in this province. And I think that there's a lot of great data out there, great information. Some of it's conflicting, but I think there's, generally speaking, a trend that shows there is definitely a relationship. When you clear cut, it has an effect on water. And I just want to take a second to do a little shout out to Dr. Bork, who is on this webinar today, who has some new research that I think you should all watch on that particular topic. It really helped us in the development of our learnings document for this project, which will be coming out this spring in case any of you want to watch for that. And just picking up a thread also of something that we were really interested in that drove us towards this study, we were watching some of those same other projects across Canada and some of those same results that Simon alluded to about comparing and contrasting natural infrastructure with gray infrastructure. Some of those results are showing that, yes, natural infrastructure can be and is often just as or more effective as built infrastructure, and it's also cost effective, tends to be cheaper. So it does a good or better job and tends to be cheaper than built infrastructure. So that really drove us to ask a question ourselves about, with our role of forests and communities and questions around flooding and climate change, you know, what is the flood abatement role of intact old forests? That's what we were trying to get at with this project. And I'll just direct your attention before I move to the next slide to that map that you see there. So the whole big blue thing, that is the whole Wolastoq St. John River watershed. And the orange outline is our case study area, which is the Canaan-Wolastoq watershed. So just for those of you who don't know where Cambridge Narrows is, that is the community, the main community in the Canaan-Wolastoq watershed. It's about halfway between Sussex and Fredericton. It's beautiful. It's on the Wolastoq Lake. If anybody is into boating or swimming, that's a great place to go. Next slide, please. Specifically, we were really interested in this particular parcel of land. This is a 350-acre forest that we own in Cambridge Narrows. The Cambridge Narrows Bridge is the one that connects the two halves of the community right there on the Wolastoq Lake that you see in the bottom corner of this photo. And the property itself is outlined in that orangey coral color. It's 350 acres of old forest. It's mostly, when I say old forest, it's mostly dominated by old softwoods like white pine and eastern hemlock, but it does have some hardwood scattered throughout, but it's really characterized by magnificent old forest. It's formerly owned by Robina Weatherly, if anybody knows of Robina, and I hope you all do because she's a powerhouse. It's now called the Robinson Conservation Forest to honor her family. So we were really curious to know what was the water regime in this particular forest and what was happening on this particular parcel of land. So if you'll just go to the next slide, please. We fussed around for a while trying to figure out how to address some of these questions before we very helpfully stumbled on Simon's project and got some really great input and expertise from Simon. So you'll see some similarities between his project and ours. We did a similar hydrologic analysis where we were curious about comparing two scenarios, the existing old forest condition to a new condition, which was projected to be that of a field or a clear cut. And we were looking at several different conditions under those scenarios, and we added a couple based on some feedback from Simon. So I think this is a really important point, that there are lots of learning opportunities to be had. There are really great opportunities for us to learn from one another when we undertake these kinds of projects. And so we looked at a 1 in 5, 1 in 50, that's new from Simon's, 1 in 100, and then 1 in 100 year plus 20% storm events. And then we also added another one, which is a 1 in 100 year 40% storm event. And that was because in discussing with Simon, we agreed that it would be maybe interesting to add that really exceptional last condition because that maybe more accurately reflects business as usual, the trajectory that we are on right now under RCP 8.5 climate projections. And so we thought it would be helpful to have kind of a lower and a higher categories of climate projections for these storm events. So I don't want you to take anything from this image because there's a lot going on there other than you should know that the property itself is those two outlined, those rectangular black outlines. That's the property. And then overlain by that, you'll see our hydrologic analysis, which was completed by engineers at Crandall Engineering. They identified 4 catchment areas that cover this particular property. So those 4 catchment areas are the green one in the top right, or sorry, top left corner of your screen, the purple one in the middle, and then the really big red and orange one that covers the majority of the image, and then another smaller one at the bottom right corner that's kind of blue and teal. So those 4 catchment areas sort of drove the results, and our results were kind of partitioned out in 4 parts, but we'll summarize them in the next slide, please. So similarly to some of the work that Simon did, we were really interested in knowing, what is the water abatement role or the water holding role of this intact old forest on this property, and how would that change if it had been clear cut? So what we found was, if you look at the table at the bottom of your screen, you see those 4 catchment areas, some changes in peak flow. And if you go to the far right column, the approximate meters cubed, the volume of water that each of those catchment areas is funneling in terms of peak flow. And so what we found, these particular results are for the 1 in 100 year storm plus 20%, so not even the worst condition. We found that built infrastructure in this case of catchment ponds, in the form of catchment ponds, would need to exceed a total of 25,900 cubic meters to replace the water abatement role of that forest. And just to put that into a little bit of context, that's about 10 Olympic-sized swimming pools. So a lot of water moving downhill into the Wolastoq Lake. And then we wanted to take that one step further, and so we asked our engineers to cost that out for us. So those 4 catchment ponds would come in at a cost of about $1 million, just over $1 million to build. And so we wanted to compare that, of course, to the current value of the property. So the current or the value of the property if it was clear cut. So we had a timber inventory done just 2 years ago, which includes the cost of the base value cost of the property. And the cost for all of that came in at about $325,000. Now let's just unpack some of that a bit. If you are the owner of this property and you were to clear cut it, you wouldn't obviously get that full 325. There is that base value of the property. So say it's something in the order of $250,000 worth of timber, and compare that to the over $1 million that it would cost to replace the values of the water ecosystem services, water-based ecosystem services of that property, over $1 million. So right now you can see that the water-based ecosystem services for this property are actually 4 times the value of clear cutting it. And so right here we have some pretty clear and obvious numbers about, some of the services that this property provides that are not normally being captured or are not well represented in most of our discourse about old forest and how it can be valued. So this was, I think, a really interesting step that we took to figure out, when we talk about valuing old forest, exactly what are we talking about? It's not just what you have, but what you can lose. And I think we think that this is a really valuable piece that others like Simon's project could build on in other parts of the province and even extrapolate to really get some of those tight flood mitigation values as a next step. I think that's it for me.